I am Anil Kumar. Welcome to my series on functions. We have 5 very important test questions based on introduction of functions to share with you. I hope they will help you to understand the concept better. We'll actually go through these questions first and then take up their solution. Question number 1 here is related to mapping diagram shown here. Based on this, you have to identify whether it is a function or not. You have to give domain and range, number of elements in domain and range, type of relation, and also represent this particular relation in set of ordered pairs. Question number 2 is to state domain and range of the following relations. We have given graph in question number 2. And then you need to use vertical line test to determine which graph is a function, right? So we have 4 parts to this. These are the other 2 graphs. You can actually pause the video, answer the question. Also, specify why it is not a function or it is a function, okay? Question number 3 is to write domain and range of relations. We have given very similar looking relations here. Perfect. 2xy equals to 1, x square y equals to 1, xy square equals to 1. You should also identify which one of these relations is not a function. Okay. The question number 4 is express the area of a circle as a function of its perimeter. Calculate the area of a circle with circumference of 36 pi. Now that is an application question, extremely important from test point of view. Here is the last question, question number 5. Consider the function rule. The output is 1 less than twice the square of the input. Use x to denote input variable and y to denote output variable. Write an equation for the function rule. So as you see, functions could be described as a rule in form of words, in form of equations, in form of table, or also in the form of a graph. So the question number 5 here kind of summarizes all our learnings, and we see how a function could be represented in different forms. So I hope this quiz will really help you to consolidate all your learnings. So let's get back to the very first question, answer and understand, or rather recall what we learned about functions. Perfect. So here is the first question for you. I would like you to pause the video, answer this question, and then look into my suggestions. Question number 1. Consider the mapping diagram of a relation to answer. So that is the mapping diagram given to you. Is this a function? That's the very first question. Now, this could really be your first question in the test paper. It's very important. What students miss here is the direction of arrow. So the direction is actually from right to left. That means this is our input and that is the output. Do you see that? So this relation is defined from here to there. And therefore, all the elements here form domain. And these elements form range. You get the concept. Now, if you do a vital error of not looking carefully, then you can make a huge mistake. So be careful. Functions is a very easy topic to understand, but difficult to answer in test papers. So now, let's answer these questions one by one. A. Is this a function? You clearly see that 3 is linked with 2, right? So that means it is not a function. Clear? 3. An element in the domain is associated with C as well as D. We are not sure what we are talking about. Is it 3 to C or 3 to D? So this relation is not a function. Is that clear to you? Perfect. Now, let's write down other answers. We need to write domain. So the domain could be written in the set form. So we say the domain is 1, 2, and 3. How many elements? And also range, right? Okay, so this is the domain. Let me say d of x. Okay, and range, let's say y. Okay, so let's say range, y elements, right? A, B, C, and D. Okay, sorry. Always these curly brackets to represent a set of. And these are the elements in my set. And when you put these curly brackets on, it becomes set of all these elements, and that is how we write domain or range. See, how many elements are in domain? So number of elements in the domain are how many? So we say number of elements in the domain are, just count them, 1, 2, and 3. There are 3 elements. And in the range, number of elements in the range are 1, 2, 3, 4. Now this is kind of important. If the number of elements in domain is greater than number of elements in range, then it is not a function. Perfect. Sometimes you're only given the number of elements, nothing else. So in those cases, if number of elements in, the other way. If number of elements in the domain is less than the number of elements in the range. See, we have more elements in the range here. That means some element at least should be related with more than one. Otherwise, it is not possible, correct? Therefore, it is not a function. Clear? Now, what type of relation is it? Now, since one of these elements in domain is related with more than one, so we call this as one-to-many relation. Perfect. Represent the relation as a set of ordered pairs. So when we have to represent this as a set of ordered pairs, we can call this relation R, and this is equal to 1 to A. So write 1 first, A later, and then 2 to B, 3 to C, and we have to write it twice, right? 3 to D. So that is how we are going to represent this as set of ordered pairs. Perfect. If you look at the ordered pair, you can see clearly that 3 is repeated with different corresponding elements in the range. That means it is not a function. So I hope that clears many doubts about functions, and that's a very good example to start with. Now let's take the second quiz question. Question number 2 will have different graphs. State domain and range of the following relations. Use vertical line test to determine which graph is a function. Now here we have given a segment, kind of. Basically, we are only identifying these 5 points, right? So we have 5 points here, to be very clear with you, and dotted line segment. Now, what does that dotted line segment means? It really means that we are only talking about these points, right? We are only talking about these points in our relation, correct? So I could write this relation as, in the set builder form, I could write this relation as, let's start from here, -2, and the value corresponding is 4. Then we have -1, and the value corresponding is 3. At 0, it is 2. At 1, it is 1, and at 2, it is 0. Do you see that? So that is the kind of relation which I am showing you here. So don't get confused with all the numbers in between -2 and 2. Only consider the points. So whenever there is a dotted line, it is just showing you a trend. It does not mean that all the elements in between also belong to the set. So I wanted to make this point clear. Now, let us answer this question. State domain and range of the following relations. Use vertical line test to determine which graph is a function. So you can now pause the video and answer the question. Correct? Well, here is the answer. As far as the domain is concerned for this particular thing, domain is always the x value. So it is -2, -1, 0, 1, and 2. As far as the range is concerned, let me write range R here, is the y values which are 4, 3, 2, 1, and 0. I could also write this as 0, 1, 2, 3, and 4. Is that clear? So it is a discrete set of elements, finite discrete set of elements. Perfect. Now here, in a circle, you need to write, and there, since we have a solid line, it is continuous, so all real numbers. Correct? So that is the difference between the two. Now let's talk about whether it's a relation, whether this relation is a function or not, right? With vertical line test. So if I draw a vertical line, it only goes through one point. Right, so every vertical line here will only go through one point, right? So it is a function, basically. Perfect. So we can say this one is a function. Correct. Now here, what is the domain and what is the range? Now all the x values are between -4 and +4. Now, in this case, we can write domain, the set of x values, as x belongs to real numbers. Everything in between is included, where x is greater than equal to -4 and is less than equal to 4. Perfect. And the range, the y values, could be represented similarly as y belongs to real numbers, where y is also between plus and -4. Correct? So we say y is greater than equal to -4 and is less than equal to 4. So set of real numbers because it is a solid line. But now, if I draw a vertical line, it intersects at 2 points, and therefore it is not a function. Is that clear? So that is how we are going to answer part A and B. Let's look into C and D. Now, here it may not be very clear. These are filled in, right? So these are solid, filled in, and these are not filled in. It's like a hole. Perfect. Now, we have to write domain range, and this is also not filled in, like this is a hole, okay? This is not filled in at -4. Now for this, what is the domain and what is the range? Here, this only shows that the graph is kind of going like this. It is nowhere close to crossing 3. Do you see that? That's what it is showing. I hope that graph is very clear now. I'd like you to write domain and range. So clearly here the domain is from -4, but -4 is not included, and it goes up to 4. Now I'll write it in a different way. We can write domain also as like this. Something from -4 to 4. So when I use these brackets, it means endpoints are not included. Perfect. So that is another way of writing the domain. And as far as the range is concerned, in this particular case, it goes up from -4 to 0. -4 is included, right? So -4 is included, but 0 is not included. Do you see that? Union means or from 2 to 4, where 2 is included, but 4 is not included. So that is another form of writing the domain and range. Is that clear to you, right? So we could also write in this form. For the next one here, which is D, the domain can be written as x belongs to real numbers, where x is not equal to some value, which is 3 for us. So it's not equal to 3. Is that clear to you? As far as the range is concerned, I can write range is y belongs to real numbers where y is not equal to 0, right? So y is not equal to 0. Is that clear? Now in both, if I draw a vertical line, here also, it only intersects at one point, which is this one. Here also, it only intersects at one point. So both are functions, correct? So these are functions. Is that clear? Both are functions, correct? So let's move on and take the next question now. Question number 3. Write domain and range of the following relations. Now this is a very critical question. I'd like you to pause the video, answer this, take your time, and then look into my suggestions. Now let us see how to solve such a question. Question number 3. Write domain and range of following relations. So there are 3 relations. The first one here is 2xy equals to 1. Let's isolate y. So y is equal to 1 over 2x. So it's kind of a reciprocal relation. If you really represent this on a graph, it may look like this. So 1 over 2x, something like this, where these lines are asymptotic to x and y axis, as shown here, right? So that is your function. So what is the domain here and what is the range? Domain here is x belongs to real numbers so that x is not equal to 0. Perfect. As far as the range is concerned, y belongs to real numbers where y is not equal to 0. Clear? So that is the y-axis, this is the x-axis. And it is indeed a function. The second one, let's try to sketch. First, let's try to isolate y to understand it better. And then we'll decide whether it is a function or not a function, and what is going to be the domain and range. So this is x squared y equals to 1, so y is equal to 1 over x squared. If you take a few points and try to sketch this, or check it on your graphing calculator, you will see that x cannot be 0, right? So x cannot be 0. So this is out of bound. But this is always positive, right? And when you sketch, you'll find it kind of like this. We are not getting into details with values, but trying to understand the concept. Now that is the graph. From here, you can easily write that the domain, sometimes we write d of x, is x belongs to real numbers. And it could have all the values except for 0, right? Like we had earlier in this example. So x is not equal to 0. Simply because you cannot divide by 0. 1 over 0 is undefined. Now let's look into the range. As far as this range is concerned, y belongs to real numbers. Slightly different from this case. All positive values greater than 0. So we say y is greater than 0. It cannot be equal to 0. Perfect. And clearly, vertical line test pass. Right. Therefore, it is a function. Correct? The last example, I'd like you to pause the video and figure out why this is not a function. Okay, let's look into it. X y square equal to 1, y square equals to 1 over x. So y is equal to 1 over x with the square root. Whenever we do square root, we do plus and minus. You get an idea, right? So that is what it is. So it is square root with 2 values. Now if I take a value of x as equal to 4, then y is equal to plus minus 1 over 2. Since there are 2 values for y, it is not a function. Is that clear to you? Perfect. Let's write down domain and range. Now in this particular case, the domain is all values which x can take. So x belongs to real numbers, as we said earlier, but what is the restriction? Well, you cannot have square root of a negative number. So x has to be greater than 0. x cannot be 0 also, since you cannot divide by 0. Correct? So that becomes the domain, and the range for this particular function will be y belongs to real number, and it is all values, right? All values. But can it be 0? No, it cannot be 0. For being 0, x has to be very large. It can only approach 0. Correct? So here, y is not equal to 0. Perfect. Now, I'm not sketching this, but that is your exercise. So your test is sketch graph. Is that clear? Of this particular function. No, not this particular relation. It is not a function, right? And then once you sketch a graph, use vertical line test to show that this is not a function. Okay? Let's move on and take question number 4 now. Express the area of a circle as a function of its perimeter. Calculate the area of circle with circumference of 36 pi. Now in functions, we are always trying to write relations mathematically in the form of equation, and we'll do so here also. So when we talk about a circle, so let's make one. Let's say this is the circle we're talking about, of a radius r. In that case, the circumference or the perimeter is basically called circumference. Let's say C is 2 pi r, correct? What is area? We know area A is pi r square. The question is, express area of circle, right, as a function of perimeter. So we want area as a function of perimeter or circumference. How can we do it? Well, the steps are very clear. C is equal to 2 pi r. Area has r in it. If I replace this r with c, we get our relation. So let's isolate r. So we get c divided by 2 pi equals to r. Now once we get this, c divided by 2 pi is r, then this particular relation can be substituted here to get the expression for area, right? So once we do that, we get area equals to pi, and instead of r square, I'm writing c by 2 pi, right? So whole square. Do you get an idea? So let's square this. So we get pi c square over 4 pi square. Now one of these pi's get cancelled, correct? So you could cancel this. And what you get is c square over 4 pi. Now this is a very, very important relation. So many test papers or even quiz, you will see, or you may have questions related to this. So let me highlight this. So what we got here is that area could be written as c square over 4 pi. Now in function notation, we put it like this. Area as a function of circumference is equal to c square over 4 pi. Is that clear to you? Perfect. So that is the answer for first part. Now we need to calculate area of a circle with circumference of 36 pi. Let's calculate. So area when c is 36 pi, so we'll write 36 pi, right, whole square divided by 4 pi. So that gives us 36 times pi square divided by 4 pi. So the pi, one of them cancels, and you can cancel this with 9, multiply 9 with 36 to get your answer in terms of pi. So that will be the exact value, right? So 9 times 6 is 54, 5. 9 times 3 is 27, and 5 is 324 is your answer. Correct? So that is the answer for part B. Is that clear to you? So that is how we could answer such a question. Now let's move on and take the last question of our quiz. Question number 5. Consider the function rule. The output is 1 less than twice the square of the input. Using x to denote the input variable and y to denote the output variable, write an equation for the function rule. Write output for inputs of -2, -1, 0, 1 and 2. Sketch a graph for the function. So I hope you get it. Let's look into this description of relation. The output is 1 less than twice the square of the input. Using x to denote the input. So x is the input and y is the output. So we are saying y, the output is means y is means equal to 1 less than twice the square of input. So twice the square of input minus 1. So that is how you could write the relation. So output y is 1 less than twice the square of input. You get an idea. So that is how you're going to write out the rule. Once you have this rule, we can answer part B. So let's make a table here to answer part B. So in a table, we'll have x and y values. The x values are the inputs for us. The y values are the outputs. Now x is taken as -2, -1, 0, 1 and 2. And y is 2 times x squared minus 1. So we'll write here 2 times. X is -2. So -2 squared minus 1. And calculate. So that is 4, right? 2 squared is 4. 4 times 2 is 8. 8 minus 1 is 7. So we get 7 here. For the next one, we get 2 times -1 squared minus 1, which is 2 minus 1 or 1. The third one here is 2 times 0 squared minus 1. So that makes the first part 0. We get -1 this time. With 1, we get 2 times 1 as 2. 1 square is also 1. And 2 minus 1 is plus 1. And with 2, we get 2 times 2 whole square minus 1. 4 times 2 is 8, and we get plus 7. So those are the values which we get as an output, right? So that is your input-output table. Now this part here is sketch a graph of the function. So it is definitely a function, since for every value of x, we have a unique value of y. When we say sketch a graph, we mean general graph where x belongs to any real number. Do you understand? So there is no restriction on x as far as the question is concerned. The output is 1 less than twice the square of the input. We are not restricting it to integers, natural numbers, or anything like this, right? So that means it's a set of real numbers, okay? So when you plot some values, which we did make a table for, just to represent them, we could make a graph which could look like this. We see most of these values are positive, lowest being -1 when x is equals to 0, correct? So the graph which you get will be like a parabola, shifted 1 unit down and vertically stretched by a factor of 2. Do you see that part? So that becomes your graph where this point is -1 for you, right? At 0, we have, at -1, so somewhere this point is not identified here, right? So at -1, the value is 1. So this value here will be, at 1 we have 1, and at -1 we have 1, right? So these 2 points, and at plus and -2 we have 7. So let's say these 2 points for us are at -2 we have 7, and at +2 we have 7, correct? So you could always find the intercepts, okay? So that is how you could sketch the graph. So here, as an added exercise, what you could have here is question 5D is find x when y equals to 0, right? That is a good question, 1. And E, state domain and range. Perfect. So these are 2 additional parts to question number 5. You can answer these questions put them in comments, and then I'll check and write down the right answers for those, correct? So I hope this exercise helps you to understand the basic concepts of functions, and these 5 questions give you a wide variety which you can expect in your test, right? So let me also show you the calculations for the x-intercepts, which is this part, correct? So you could do it like this, isolate, right? So we have to put y equals to 0, says 0 equals to 2x squared minus 1. Bringing 1 here, we get 2x squared. So x is equal to 1 over 2 square root plus minus. Is that okay? So these points are minus. You could also write this as square root 2 over 2, right? Or you could write like this, which is 1 over square root 2. Either way, but normally we rationalize and then write. So just a note, very important. Note here, rationalize. Denominator. So avoid writing square root in the denominator. That is kind of a caution to you, right? So in most of the cases when we write solutions to questions and functions, we avoid writing square root in the denominator, so we rationalize them. Okay, so with this we come to an end of the video. If you like and subscribe to my videos, that'll be great. Thanks for watching, and keep sharing my videos with your friends. Thank you and all the best.